And given that we looked at Mike's prototype board before, I've got one from Schmart Board again. You've seen them on the Mailbag before, so they're coming back for seconds. And we have bare circuit board. Description, value $5 from Neil. Thank you very much, Neil. Schmart Board, ink. So let's rip this sucker open. It'll be another one of their Schmart boards. I'm not sure what they're sending me this time. Ta-da! Let's have a look. That's it. You can now solder practically any surface mount component quickly, easily, and flawlessly. Oh, it looks like there's actually a chip attached to this one, so we'll get right into that and check it out. So let's take a look at what Neil has to say here. Dave, you were nice enough to talk about us recently in the Mailbag. No worries, thanks for sending. You're as entertaining as ever. We all enjoy watching your videos here at Schmart Boards. Perhaps to us Americans your voice is reminiscent of Steve Irwin, the crocodile hunter who was beloved here. What? I've never heard that before. I sound like Steve Irwin? Crikey! In the Mailbag you discussed one of our Arduino SMT prototyping shields with 1.27mm pitch and had mentioned that you thought our technology was a slight advantage over a regular PCB. Well, yeah, 1.27 is not that difficult to solder, so it really did not offer a true representation of what we have to offer. Fair enough. So they're having a second suck of the sav here. Not a problem. I've included one of our prototyping boards for a QFN 88 lead 0.4mm pitch. Oh, what an evil piece of work that will be. Yeah, this would be challenging for anyone to solder by hand. You're not wrong, 0.4mm is about as small as it gets in the industry in terms of pin pitch, and that would be a real bastard to do on an ordinary board, assuming that you can still get the solder mask between the individual pads on there. Anyway, I think you will notice that an IC will hold in place on the board and solder is already on the board in the grooves. All that is needed is some solder flux and a soldering iron tip smaller than 0.4mm, because you run, they've included a photo of it here, you run the, this is where the pointed soldering iron tip, which I find useless for a good majority of stuff. I like using the chisel, but here is one use of the fine conical tip soldering iron, which you usually get as standard on a lot of irons. Yeah, you can get right down in that groove. I'm not sure if I got one that's 0.4mm. I'll have to have a look. Okay, let's have a look at this chip. It's a Green Arrays GA32G18. Never heard of them. Look at this, internal use only. I wonder what is the go there. I'm going to have to Google this sucker. Not that it actually matters at all, but I've never heard of Green Arrays. Well, what do you know? It's a multi-core processor. I've never heard of these things. This GA32 is a 32, I believe, a 32-core low-power processor. I'm not even sure what technology the core is. It's definitely not ARM or anything like that. It's sort of their own custom thing. I only very briefly looked at it, so check the Green Arrays website if you want to have a look at more of that. But you can get up to the GA144 model has 144 processor cores in there, allowing you to do you know, parallel multi-processing and all that sort of stuff. So fascinating. Who knew? Whew. Anyway, this is supposed to be taking a look at the soldering. So let's take a look at the pin pitch on this thing though. 0.4mm, you little bastard. Man, what a dog of a little chip to solder. Anyway, this will be a real test of this Schmart board. So let's give it a go. It's supposed to sit in, I haven't even got it lined up properly yet, but it does sort of seem to fit in there like that. And they say you can do this without a microscope, but it's supposed to sit in a groove where you can't easily move it from side to side, and it seems to do that. Look at that. That is an absolute dog. 0.4mm. You know, you need the solder to reflow under the pins on here and up. All right, let's give it a go here. I'm going to use my Electrolube flux pen here. So we're going to put some flux under this sucker and then line it up. All right, we seem to be lined up on all four sides here, I hope. Dab some more flux on there. Hold this in place. Just get a bit more down in there. So we've got some on the chip, the pins of the chip as well. Really does sit into the grooves in there, and they're probably right in that you don't need a microscope for that. Although I would certainly want to double check that with a good microscope first before I soldered it. But once it's in place, of course, once it's aligned, then it really doesn't seem to move. I have my finest conical tip here. I haven't used it before because not for my Hakko FX 888. It's a little tiny conical tip. This is rather hard to do when you're on camera like this, because I've got to stand up doing this from behind and from behind the camera with arms extended. So and I can barely get my eye in the correct orientation. Oh, there we go. There we go. Oh. Yeah, sorry folks, this is me trying to look at the camera instead of the board and reflow this thing. So this is not the best example, but I can see how it's going to work. Like, I can't see that. I'm pushing some of the material up in there. Oh no, see what my tip has done? It's gone between the solder points. So it looks like my tip is not fine enough. Okay, let's try this JBC tip I've got here. It just so happens they supplied me this one. It's the C245030. It's a very tiny fine point conical tip, and if we have a look at their range of conical tips here, you'll see it's the smallest at 0.3 millimeters, smallest one they make. So it should be ideal. If we can't do it with this, then I don't think we're going to be able to do it with anything. All right, I've got this set to 300. There it is. Let's give that a go. Well, as it turns out, you really do have to do this under a microscope, at least for the first couple of times, to get a feel for what's actually happening there on the pins. And I've had to set up my camera here in the vertical reverse tripod configuration that you've seen in a previous video to look directly down onto the chip, and you can see the solder melt and then drag along. But you certainly must have the correct size tip. If it's too big, you're going to get into the FR4, and if you apply too much pressure, you're going to rip all that FR4 off instead of getting into the solder groove there and dragging that solder along. So there you go. If I can do the entire length like that, you should have just the right amount of solder to reflow that pin. That seems to be doing the business. I'll have to inspect this under the microscope, of course. I don't think this is something you can do without inspection. I really do think that you need inspection gear to go along with this. You can't just do it willy-nilly and then hope that it's going to work. Now, I won't know until I view this on a high definition screen, but you can probably see that those joints aren't really done there. There's one or two that maybe look like they've caught onto that and reflowed that pad, but in general, no, I think we haven't done the business there. So let me try another side. The alignment was slightly off on that side, so the alignment on the other side here looks a lot better. So let me apply some fresh flux on that and give the other side a go. Alright, I've used the correct tongue angle and I've applied a large dollop of flux on there, so let's give this a go again. Look at that, you can see that solder reflow all the way up to there. Excellent. So it does exactly as they claim, in that you reflow the solder in that groove and then it goes boom all the way up there. Whether or not it's catching on those pins, of course your iron can't get onto the pin, so you're relying on the flux and the molten solder to get under the pin on that package and then reflow that pin as well. So I won't go through and do them all. Let me double check that. And there it is. Once again, I haven't really got it to reflow onto the pins. It is a liquid flux. It should have flowed under the chip there onto the pin. I would have expected that to actually work. So maybe it's the chip itself. I mean, this is not a fresh chip. It's been in transit. I'm coming in sealed packages. I've mentioned this on previous blogs. So maybe that's why it's not taking. We've got some corrosion there on the pins of the chip, and it's not taking. Perhaps that's all I can think of, because there was quite a reasonable amount of solder there and quite a reasonable amount of flux, and I would have expected that to reflow, but it hasn't. Bummer. Or at least it hasn't right like up on the side of the chip. Maybe it's caught underneath. No, it definitely didn't take on the bottom of the chip, because I was just able to lift the chip up then off camera, so it didn't take at all. So really, I don't know what the deal is. I'm using the smallest JBC tip possible, 0.3 millimeters. I'm dragging all of the solder over that pin. You can see it reflowing. Maybe I need to hold it there a bit longer, but well, when in doubt, raise the temperature, I guess. I've got it set to 350 now, and let's drag that in there. I can't believe I can't get it to take. There is quite a lot of flux on there, and it should. You can see the flux. You can see it there. Can't believe it's not taking to that pin in there. I think we've got a dodgy chip, folks. I really don't like this. We've got one! My best Ghostbusters impersonation. Sorry about that. It's really quite hard to get this under the ×10 mag here. I'm hand holding this, but you can see smack in the center of the image there that quite a few of those have soldered very, very nicely. Now I've actually cleaned all this up, so you should be able to, so there's no flux residue left on that, so you should be able to see those joints perfectly in there. And yet some of them have just not taken at all. So it, you know, this thing seems to do exactly what they claim. You put your 0.3 millimeter soldering iron in there, and it does reflow the solder in the little groove. It goes all the way over, and you put your flux in and it all reflows, and there's no solder bridges and perfect amount of solder and all that sort of stuff, but it still has not reflowed. So I suspect that is probably the chip that we've got. So I don't think it's any failure in the Schmart board as such. Otherwise, this actually worked quite a treat once you got the hang of it. But you really do have to get the hang of this thing first. It's not something that you can just walk up to and do. I think you really need that inspection gear to check and do a few tests first. And once you got the hang of it, it is very easy and very simple. I do like it. No solder bridges or anything like that. But I'm actually going to now, with a bit of practice, I'm going to actually go back to the Hakko conical tip and give it another try on the other side of the chip. Alright, so we're back on the Hakko tip here. So let's give it a go. One thing I found though, this side over here is the side that we soldered before, and now I found that this chip has actually raised itself up on this side. So you've really got to apply pressure now. I found that I've got to apply pressure on the chip on this side. See? You can see it there, and now I'm pushing down and you can see all the flux just move like that. So let's... No, there we go. The Hakko is... There we go. I think I was just too ham-fisted before with the Hakko. It seems to be... Yeah, I didn't have the right angle. I was too ham-fisted. You really have to be quite gentle with these things, otherwise you're going to scrape off the FR4 there in between the grooves. But off, you can't really see the final solder joint until you clean that flux. Quite enjoyable. I really like this. It really is quite neat. No, I don't think it's taken, because you can see that I can still push the chip down there. No, I'm afraid not. I didn't get a single one of those to take. Look at that. Bastard. So, yeah, I do believe this concept can work, but I think we need a better representation of a of a fresh chip straight out of the package, I think. Anyway, that was rather interesting. Now, just out of curiosity, I'm actually going to run over this with just my regular chisel point with some solder on there and see what we get. And check it out, folks. Ironically, using the chisel point, I was able to get in there and perfectly reflow all but one of those pins. Not a problem at all. Yeah, there's a little solder bridge there between a couple of pads there, but no big deal. That seemed to have worked much better than getting the chisel point in there. Maybe I'm not using the correct chisel point, but I am using a 0.3mm in a, on a 0.4mm pitch device, which is what they recommend using, a smaller chisel point. And it dragged the solder along fine, but it just didn't seem to take like it did with that drag soldering. So not sure what the deal is. Let's see if Schmart Board can come back with an answer on that, because maybe I'm just not doing it right, or but once again, I think this chip is quite old and the pins are oxidized. Of course, that solder drag system is a time-honored method of soldering prototype chips like this, and it does work, but of course it's very reliant upon the amount of solder and your skill in actually doing it and how much you've practiced and things like that, and especially the solder mask between pins in there. And if you don't get the solder mask in between pins, well, that can ruin your day, especially on a very fine pitch one like this, 0.4mm. Unbelievable. Okay, well, I did have some success there before by raising the temperature, so I've raised it even more. I've got it up to 385 using the JBC, and let's see if we can let's see if we can reflow this. Yeah, it's really sizzling, of course, so possibly we might get some reflow on there. I mean, I don't recommend you use this higher temperature. You shouldn't have to on a well-prepared chip. And I've got the angle there. I'm probably at 20-degree angle. I'm quite a shallow angle. It looks like the angle's higher on camera there, but it's not. It really is quite a shallow angle. And I'm leaving it longer, slightly longer on the pin for about a second or more, just to let that molten blob sort of pick up on the individual pin. And of course, you know which one you've already done because it changes color there. Oops, did that? Oh, is that sort of sliding out of the groove there? Oh, something went horribly wrong there, folks. Yeah, look, it just jumped out of the groove. Check it out. Yep, 385. You don't want to use 385 degrees on this thing. It's too high, but anyway, let's see if we get a result on that. Nope, no, one or two maybe there, but no, still didn't do it at 385. Bummer. Alright, well, let's have another go with the drag soldering technique and see what happens here. And check it out, folks. Every single one of those absolutely perfect. Not a problem, because it helps having this well-based, these little grooves, this little well-based system there, so there's no bridges. So these Schmart boards really do work quite well, ironically, for drag soldering across the chip, like along the pins, as well as into the pin using the groove system. I mean, I just, bang, straight across there, just a couple of wipes, and it was done, and every single one of them is perfect. So I can only presume that there probably just isn't enough solder in the grooves on the Schmart board to do this particular chip. I think if we had another one brand new, straight out of the moisture absorbing factory packet, it would take no problems at all. So that's the only reason I can think of, is that the my drag method with the chisel point, I had a quite a large, relatively large ball of solder on there, and it really just got in there and got straight onto the pins perfectly, as opposed to using the groove system. But the groove system did work. I did show it. I was able to get pins working in the previous clip, so yeah, it's no problem. I think it's just a dodgy chip, but I really do like this groove system. It is possible to really get your soldering iron tip in there, and it really does seem to work quite well. And I think it was just a poor example with the oxidization on the pins there, because that certainly had enough solder and flux to work. So I'm sure it does work as claimed.